In our lesson today, we're going to have a look at solving some exponential equations and some inequalities as well. We're going to look at a variety of situations to solve different types of exponential equations. Right now, the underlying fact, or in other words, if I want to say, give you a hint in terms of this particular topic, right? What we're going to try and do is we're going to look at all the numbers in that equation, and we're going to try to see if we can form a relationship between those numbers in the form of, are they powers of some other number? For example, if we take, let's take 8 and 16 for example, right? They both are powers of 2. So that's the common link between the two numbers there, right? So that's what we're going to try and look in each scenario first, right? Because once we try and achieve a relationship between the numbers in the question, solving an exponential equation becomes so much more easier, right? So with just that, let's jump straight into some examples, right? So we have the first question where they want us to solve the equation for x. So we have 5 to the power of minus x is equal to 1 over 125, right? So obviously the two numbers we have dealing with in this particular question is 5 and 125, right? And obviously, as we know, that these two numbers do form a special relationship, and the fact that 125 is nothing but 5 to the power of 3. Alright, so like I said, that's what we're trying to achieve first. We like to make all the numbers having the same base, or try to bring all the numbers as powers of one common number. So that's what I'm going to do first. I'm going to rewrite the 125 in the form of 1 over 5 to the power of 3. Right? Now if I bring that to the numerator, right, it's going to end up getting a negative power. So I'm going to have 5 to the power of minus 3. Now we have an equation where the bases on both sides, they're one term on either side first. The bases on both sides are the same, right? Which means now we can equate the powers of this particular. So equating the powers of this equation is going to lead us with minus x is equal to minus 3, right? Dividing both sides by negative 1, right? We're going to end up having x is equal to a positive 3. And that becomes the solution to this first question there. Alright, so we tried to make everything with the same base. So we changed 125 to 5 to the power of 3. Then we brought it to the numerator. We equated the powers. And then we solved for x from there. Right, let's move on to the second question. Right, second question is a slightly more complicated one. Right, where we have 2 to the power of minus 3n times 4 to the power of 2n minus 2 equals 16. Right, and again, in this question, the numbers we're dealing with are 2, 4, and 16. And what do they have in common? They're all powers of 2. So that's what I'm going to do first. I'm going to first rewrite the equation with all numbers being powers of 2. So 2 to the power of minus 3, and we can't change that, so we're just going to leave it like that. Now 4 can be written down as 2 squared. So 2 squared in brackets 2n minus 2. Make sure you're using the brackets. It's really important, otherwise you're going to end up making a mistake. Right, equals 16. 16 is nothing but 2 to the power of 4. Right, now on the left hand side we have two terms multiplied with each other, both of them having the same base, right, which is basically going to allow us to use the very first index law, right, where we can add the powers. Right, so if I add the powers, I'm going to have 2 to the power of minus 3n plus 2 times 2n minus 2 equals 2 to the power of 4. Right, now again, right, we have a situation where we have only one term on either side having the exact same base, right, which means we can now equate the powers, right? So we can equate the powers as minus 3n plus 2 times 2n minus 2 equals a positive 4. Right, now that we have an equation in a normal linear format, right, we can now go ahead and solve this equation for n. So I'm going to go and expand that bracket. Minus 3n plus 4n minus 4 equals a positive 4, right? So it gives us n minus 4 equals 4, giving us a solution for n as a positive 8. All right, and that completes that particular question. Right, moving quickly to a third example. Right, and again in this particular question the numbers we're dealing with are 27 and 3, right? We know that they're all powers of 3. Right, so we're going to convert them into powers of 3 first. Right, so I'm going to have 27 written down as 3 to the power of 3 times 3 to the power of x to the power of 2 equals 3 to the power of 3 in brackets, right, to the power of x times 3 to the power of a half, right? Now, on the left-hand side, obviously, I can give each of them the powers of 2 if I want, right? So let's do that, right? So 3 to the power of 3 times 2 is 6, times 3 to the power of 2x equals 3 to the power of 3x times 3 to the power of 1/2. Right? Now, I want to try and achieve one term on either side of this equation, right? So we're going to apply the first index law to both sides of this equation, right? So we're going to do that first. So adding the powers on either side, so 3 to the power of 6 plus 2x. I bet 6 plus 2x is equal to 3 to the power of 3x plus 1/2, right? So obviously now we have one term on either side, we can now equate the powers, right? So 6 plus 2x is equal to 3x plus 1/2, right? Now we just need to go ahead and solve this equation for x, right? So I'm going to start by minusing 2x on both sides to start with, right? Giving us with 6 equals 3x minus 2x is x plus 1/2, right? Now one final step to solve for x. X is going to be equal to 6 minus 1/2, right? Which is going to be just equal to 11 on 2, right? And that solves this equation for x in this particular scenario. Right. Let's move on to an inequality, right? We have an inequality, right? Is it going to change the way we go about this question? Definitely not, right? So what we're going to first do is we're going to try to look at the numbers again, and we're going to try and achieve the numbers with the same base, right? So 3 and 81, and I know they both again have a special relationship. 81 is nothing but 3 to the power of 4. So that's what I'm going to do first. So 3 to the power of 2x minus 2 is less than or equal to 3 to the power of 4. Now again, we have achieved one term on either side with the same base. So we're going to again equate the powers, right? This time we're going to equate it with an inequality. So 2x minus 2 is less than or equal to 4. And from here onwards, we just have to solve for x, just like how we would do with the normal equation. So 2x is going to be equal to less than or equal to, 6, right? Which implies x is going to be less than or equal to 3. Now, in this particular scenario, right, it ended up being a very simple inequality, right? Just remember when we're dealing with inequalities, anytime you multiply or divide with a negative number, you just have to flip the signs, which we didn't have to do in this particular example. So, but just keep that in mind. Right, now, moving to an example where we have to use a calculator, right? So we have a situation where we want to use a calculator. The reason why we need a calculator is this, right? The left-hand side of the number is 10 to the power of x. The right-hand side of the number is 56, right? Now, they both don't share a common number that forms a power of 56, or a number that leads with the power to 10, right? And that's a possible reason. 10 and 56, just in this particular scenario, don't share that special relationship like we had in the previous examples, right? And that is the reason why we need to use a calculator to solve for this question, right? So there's a couple of hints, right? Obviously they want us to 2 decimal places. That straight away gives you the hint that we have to use a calculator. Right, so I'm going to go load up my calculator software, right? We're going to open up a calculator page, right? Just basically from here, menu, algebra, solve, right? We have 10 to the power of x equals, just make sure you come out of the power, equals 56, and then we're solving it for x by putting a comma x, control, enter, boom, done. So 1.75 correct to 2 decimal places. So which means, let's just write down the answer, x is equal to 1.75, and that's it, and that's all you have to do for that particular question, right? Now, to the last and, in my opinion, the most important question in terms of solving for exponential equations, right? Now let's look at this question. We have 9 to the power of x is equal to 12 times 3 to the power of x minus 27, right? Now, if you are in the VCE subject, then you would notice that this is a question that's been often tested a lot in exam 1, which is your non-calculator, no reference type of exam, right? Now, in this particular question, it is so different to the previous ones, right? Now, on the left-hand side, I have one term, 9 to the power of x equals 12 times 3 to the power of x, take away 27. Now, unlike the previous examples, right, where all the operations involved in the questions were multiplication and division, in this particular question we have a subtraction involved in this, right? So 12 times 3 to the power of x minus 27, right? Whenever we have an addition or subtraction, unfortunately our index laws don't really help a lot in that situation, right? Now, believe me or not, in terms of this particular question, this is actually a scenario of a quadratic equation, right? And let's see how that all comes into play, right? The two exponentials in this question are 9 to the power of x and 3 to the power of x, right? And both 9 and 3, they both form a special relationship, right? We know that 9 is nothing but 3 to the power of 2, right? So that's what I'm going to rewrite this question as. So I'm going to rewrite 9 with 3 to the power of 2 to the power of x equals, I'm just going to rewrite this entire question the way it is, minus 27, right? Or in other words, the left hand side can also be written down as 3 to the power of x to the power of 2, right? Same thing at the end of the day. Right? And you'll see why I have written it in that particular format. Right? Now what I'm going to do here is I'm going to replace the 3 to the power of x with some other alphabet. Right? So I'm going to say, hey, let 3 to the power of x be equal to y. Right? And then once I do that, right, I'm going to replace 3 to the power of x with y. I'm going to end up having y squared is equal to 12 times y, or just 12y, take away 27, right? If I bring all the terms over to one side, I have y squared take away 12y plus 27 equals 0. Boom, there you go. That's your quadratic I've been talking about at the start of this question. Right, so we have a monic quadratic equation, right, which we can factorize. What are the two numbers that multiply to give me 27 and add to give me a minus 12? That is a negative 9 and negative 3, right? So we're going to use that. So y minus 9, y minus 3 is equal to 0, right? If I apply my null factor law, my two solutions for y are y equals 9 and y equals 3. Alright, so I've solved for y, but that's not the whole point of this question. This question wanted us to solve for x, right? So we want to solve for x, which means we're going to replace it back with 3 to the power of x, because y is nothing but 3 to the power of x. So that's what I'm going to do here next. Alright, so 3 to the power of x is equal to a positive 9, and 3 to the power of x is equal to a positive 3, right? Now 9 we know is nothing but 3 squared. Right, so if I equate my powers here, my first solution for x is equal to 2, right? And similarly on the right hand side, right, we have 3 to the power of x is equal to 3, which is nothing but 3 to the power of 1. Equating the powers, my second solution for x is equal to 1, right? And with that we complete this question, right? So just quickly recapping this particular one, right? We have an equation where there is a subtraction involved, right, which really limits us the use of index laws. Right, so what we first do is we look at the exponentials in this question. They both are 9 and 3, right? 9 is written down as 3 to the power of 2, right? Then we replace 3 to the power of x with another alphabet, leading us into a quadratic, which we have here, right? We factorize the quadratic, then we replace it back to solve for x. Right? I would really suggest you watch this example 2 or 3 times before you attempt any further questions in this particular topic. Right, that's the last one for today. Right, thank you for watching and have a wonderful day.